consider two complex valued functions x1t and x2t. Then that projection of this first function onto the second, that is defined as x1t into x2 complex conjugate of the second, this one. That is the projection operation. Okay, and I'm using a notation for this because we'll be using this integral quite often, so I don't want to write this integral every time. So there is a notation for this. This is x1t x2t. I'm writing this notation. This is defined as this integral. Okay, and those who have studied linear algebra, you are familiar with this notation. What is this notation used for? What is it called?
Inner product.
Inner product. Okay, that is a notation for use for inner product, and in fact this is an inner product in the function space. Anyway, we are not going into the details of that. Okay, now let us consider we are talking about complex exponential. They are the basis functions. That means any given periodic function with period t naught can be expressed as a linear combination of this. Linear combination means for different values of k. That is the so that's why we call this basis functions for different values. Now, what about this? If you consider e to the power j k omega naught t, and this is the kth harmonic, because the frequency of this complex exponential is k times the fundamental frequency. Now, what about this? I am considering kth harmonic and mth harmonic. What about this integral? It is 1 upon t naught integration over t naught. And what is this notation? I think I have explained this in the previous class. What is this notation? I'll be using this notation. When we integrate periodic signals, the integration is over one period. Okay, when we integrate a periodic signal over one period, we can choose any continuous interval of length t1. For example, if you consider a periodic signal, if you want to integrate it, you can okay, let's say this is a periodic signal. You can integrate it over this period, or if you integrate this over this period, it is any continuous interval of length t naught, you will get the same integral, isn't it? Same value. That's why we generally represent like this the integration over of periodic signals. This is integration over any continuous interval t naught, one period of that periodic signal. Okay, so what is this integral? If you use this this definition, is it e to the power j k omega naught t into what is this is the first function into complex the conjugate of the second function. Multiply those two, integrate over one period. That is this operation. Okay. Now, what is the conjugate of this second function? Is it e to the power minus j? Is it this? Can we simplify this integral?
So delta of kn.
So this is 1 upon t naught integral k minus m omega naught t dt, isn't it? Now, what will happen when k is equal to m? This is equal to what?
1.
This is equal to 1 because this is 1 integration over one period. So this will be t naught divided by t naught, that is 1. So that is when k is equal to m. Now, what will happen when k is not equal to m?
0.
When k is not equal to m, it is 0. Why? What is the reason? When k is not equal to m, why is it 0?
Sir, because if we break it into its component cos and sine, then the integral will be 0. And in
Why?
this case,
No, why the integral is 0? If you are, what is k and m are what? They are integers. Are they integers? Here we are considering kth harmonic and this is the mth harmonic. K and m are integers. So k minus m is an integer. So what is the frequency of this signal? I am asking about the frequency of this complex exponential.
So
What
k
is it?
minus m omega naught
It
divided
is
by
k
t.
what divided by t naught. K minus m into omega naught. That is the fundamental frequency. Is it? What is the fundamental frequency of this kth harmonic? It is k times omega naught, isn't it?
Yes.
Yes, sir.
So this is k minus m times omega naught. And k and m are integers. So we can say that the fundamental frequency is an integer multiple of omega naught, isn't it? Is it? Now we are integrating over what? Integrating, what is the that interval? T naught. Okay. Now can you tell me, okay, this is a real part of this is sine and imaginary part is cosine. So if you integrate sine and cosine over one period, it is always 0, isn't it? And when you take t naught, how many periods we are integrating? This integration?
K minus m.
We are integrating k minus m periods, isn't it? And this is an integer, so it is always integer multiple of that t naught, isn't it? Fundamental time period. So can we say that we are integrating over k minus m in that periods of that complete periods of that corresponding sine and cosine signal?
Yes, sir.
That's why it is 0. Okay, and we can write this as what we have shown here is e to the power j k omega naught t, e to the power j m omega naught t. That is, we can write it as delta. What is the meaning of this? This is
So
1 when,
1.
this is
1
1
if
when,
k is equals to m.
when k equals m, it is 1, otherwise it is 0. Omega naught t e to the power j m omega naught t. When k is not equal to m, they are orthogonal because this is 0, isn't it? They are orthogonal. So we can say that this e to the power j k omega naught t, they form a orthogonal basis. They are orthogonal basis because for different values of k, we are using the linear combination or the harmonics from 0 up to infinity. Sorry, it is minus infinity up to infinity, isn't it? All the possible values of k, all the integer values of k. So they are all of them are orthogonal. It is an orthogonal set. Okay, if we consider all the complex exponentials for these values of k. Okay. What is the period? Is it a periodic signal?
Yes, sir.
It is a periodic signal with what? This is the fundamental period. What is the fundamental period? What is fundamental period?
The smallest period in which it
Smallest
repeats.
period in which it is periodic. That pattern repeats, right? So it is this is periodic with 2 t naught also, but t naught is the minimum value is the fundamental period, and the corresponding frequency is the fundamental frequency. Okay.
Okay, sir.
So what is the fundamental frequency of this? E to the power j k omega naught t?
K
Is it
omega naught.
k omega naught is the fundamental frequency of this complex exponential. Okay. Okay, so now we can, using this result, we can find the Fourier series coefficients. Xt, if you are given a periodic signal xt. Okay. Now suppose I want to find, this is k from infinity to infinity, I want to find the mth Fourier series coefficient. So what we have to do is, remember in the case of vector space, what is the operation? It is the dot product between that vector and the mth basis vector. So here the operation is, what is the basis function corresponding to this?
E to the power jm omega naught.
E to the power jm omega naught t. So compute this. What is this? It is 1 upon t naught integration over t naught xt into e to the power minus j omega naught t, sorry, minus m omega naught t dt, isn't it? It is that integral. Now if we put this value of xt here, it is 1 upon t naught integration over t naught summation k from minus infinity to infinity ak e to the power j k omega naught t. Okay, this into e to the power minus j. I'm substituting this value of xt here, this Fourier series representation. Now can we simplify this? We can write this as okay, so here it is ak into e to the power j k minus m omega naught t dt. Okay, now tell me what is this integral?
Del k minus m.
It is not del k minus m because I am taking 1 by t naught here. If it is 1 by t naught, then it is del k minus m. So can you tell me the answer? This is non-zero. We can say that this is non-zero only when k is equal to m, isn't it? This is non-zero only when k is equal to m. Is it? This integral?
Yes, sir.
Yes. Then what is this? Is it this integral is non-zero only if this is summation over k, and this is non-zero only when k is equal to m. So only for one value of k this is non-zero, and for that value this integral is what? Is it integration over t? When k is equal to m, this is 1, isn't it? So integration over t by t naught, t naught by t naught, that is 1. So is it am?
Yes, sir.
This because this is we can write this as summation over k minus infinity to infinity ak into 1 upon t naught integration over t naught e to the power j k minus m omega naught t into dt. Okay, this term is 1 when k is equal to what?
When k is m.
When k is m. For all other values of k, it is 0. So this summation, there will be only one non-zero term, that is am. Okay. So what we have seen is, if you want to find the mth Fourier series coefficient, this is the operation. Okay. So we can generalize this. If you want to find the kth Fourier series coefficient, what is the operation? Is it this? Is it the operation? If you want to find the kth Fourier series coefficient?
Yes, sir.
Yes, sir.
And what is the corresponding integral? It is 1 upon t naught integration over t naught xt e to the power minus j k omega naught t dt. Okay. And this is called the Fourier series analysis equation. This is called the Fourier series analysis equation. Fourier series analysis equation. And this one, xt in terms of that Fourier series coefficients, this is called the synthesis equation. Okay, Fourier series synthesis equation. Okay, this property I forgot to mention, e to the power j k omega naught t Okay. That is called the orthogonality of complex exponentials.